I'm going to do a little surveying tutorial here, kind of quick and dirty. Might be kind of lengthy to explain, but I'll do my best to keep it clear and make it make sense. So the idea being that when you're surveying, you want to find the boundaries of a deposit of ore underneath the surface, and you also want to come out of that with some idea of how much ore is in that area. That will help surveyors decide whether or not it's worth setting up a mining operation at that deposit and running the track out to that location, and setting up our communication systems and the porter boards and all that stuff, the miners tracking system for their tools and getting the blacksmiths involved, all of that stuff, whether it's all worth what's in the ground at this deposit. So the way you do that is you try to get a pretty good estimate of what's under there, and short of digging it all up, there's really no way to tell for sure, but using some math you kind of get a pretty good idea. So I'm doing this all with a bird's eye view of a map here. Let's say that this is grass, and this might be some forest over here, and this is some water, and you're bopping along, and you come across a little piece of ore. Maybe it's poking out of the ground, or you've discovered it a couple layers deep or whatever. You want to there's something here, so you want to figure out how much is here. And the first thing you need to do is figure out how far it goes in all directions. So ores can be, or deposits are kind of cloud shaped, and they're to a certain extent kind of random. You don't know exactly what the shape is, and you don't know exactly how dense the deposit is or how deep it runs. So you've got to kind of get a sense as to what's under there, and it's you can kind of eliminate, or through the process of elimination, you can kind of figure out roughly what the shape is. So let's say, I'll start right here. Let's say there's a piece of ore sticking out here, and we want to figure out what the boundaries are. So the first thing a surveyor will do is start digging in one direction until they stop seeing ore. And usually it's a good idea to go 10 blocks past the last spot where you've seen ore. Like you're doing this in a tunnel, maybe underground. So dig 10, 15 blocks past where the last spot you've seen ore in your tunnel. And it's a good idea too, when you're using your coordinates, to do things to the 0, or to, if not the 0, then to the 5. So if this coordinate was negative 313, just keep going to negative 320. It's a nice round number to work with. A couple blocks off here and there isn't going to mess up your overall estimation by too much, and it'll make your math a lot easier. We're not it doesn't have to be a precise thing. It can be still very accurate without being precise to the block. So you want your numbers to be nice and round. So negative 320, you'd keep going, and then you go in this direction till you stop seeing ore, and you'd have yourself a tunnel. Then what you do, this is where it becomes a little tricky. So let's say it was negative 320. I'm just going to write that down. It's really hard to make this stuff easy to read in Photoshop here. Yeah, try that again. So let's just say that's negative 320 up here. And you get down here, and this is, let's say that's negative, let's make that, say it's 260. Okay, so the next thing you do is you want to find the halfway point of this tunnel. So you find the difference between these two coordinates. You know that they're 60 blocks different. So 30 blocks is the halfway point. That'll get you to negative 290, by the way. So negative 290 is your halfway point. Then what you do is you dig east-west, doing the same thing. Let's say that's 400. And you dig this way, whoops, and you dig this way until you stop seeing where, oh, this is a big deposit, right? And turns out this is, let's just use nice round numbers just for the sake of this thing, 300. So you've got 300 by 400. So it's looking like it's 60 north-south and 100 east-west. Okay, well this clearly isn't going to be your center of the deposit. As you can tell, it's quite wide. And if the deposit is shaped anything like an ellipsoid, which for all intents and purposes they usually kind of are, that's not your halfway point. So you're going to be missing out on some stuff. You know, if it's like this, you're going to be missing out on, maybe there's some more ores up in here if you were doing it more towards the center. So then what you do is you find your halfway point between 300 and 400, and you know that that's 350, which would be right here. I guess you don't really need to see that. And then you do another, okay, so it's not much of a difference. You do another tunnel. Now, if there's not much of a difference between the halfway point of this, let's just say that this is still 320 and this is negative 260 still, you can go, okay, so this isn't much of a difference. So that's good. There's the middle of your deposit, and you know, and when you look at it, I mean, it is pretty close to the middle. That's going to give you a pretty accurate sense of what the boundaries of this deposit is. And if you were super particular and it was a really odd shape, you could find the halfway point of this again and then do like another east-west, but you wouldn't need to do more than one more. But this should, usually 3 is enough to do it. So now what you know is that negative 320 by 260, and then on your east-west 300 by 400, those are that's the boundary of your deposit. Well, not quite, right? But that's the arbitrary part of the shape of these things. So if you were to mark that area out on the ground for the miners as their mining boundary, they'd be able to dig up most of that deposit. There would be very little left over, and it would be a very good survey, and you wouldn't have them doing extra digging for nothing. So with that in mind, that gives you the boundaries, and what you want to do now is find out how much is in there, and you've got to get a sense of a couple other things. You need to know how deep it runs, so you dig from the middle, you would dig down, let's see, you dig down, this is the only way I can really do it is kind of like do this. And then say you're digging down and it goes, you're digging down until, you know, you stop seeing ore 5-10 blocks. Let's say that works out to be 30 blocks deep. You know, actually it's at this point where I should mention that to get the most accurate read on the deposit would be to do the depth first. So rather than starting off doing the north and south and then the east and west tunnels, you'd want to dig down and find how deep it goes. And then you can find the midpoint of the depth. So for 30 down, midway down would be 15 blocks deep. So you dig down, you find out it goes 30 blocks deep, and then you come back up to the halfway point at 15. And that's when you would start doing your north and south tunnels and your east and west tunnel. That would be the best way to do that. That way you're not just measuring the top of the ellipsoid, you're measuring right through the heart of it. So now you know you've got a deposit that's 60 by 100 by 30. And that's great. If you're doing a cube, you want to know what how many blocks are in this cube. It'd be 60 by 30 by 100, but we're not actually measuring a cube because that's not the way ores are generated. They're kind of clouds, and they're more ellipsoid shaped. And they're not solid. Often they're not solid. So the next thing you need to do is find out how dense this deposit is. And you can do that just by walking down one of your tunnels. And if you place a torch, say we're going to start here at let's start over here at 320. You place a torch here, or something, a marker, a surveyor's marker, and you walk 10 blocks to 330. There's an area where you've got a sample of how much ore is in a 10 block area. Now, you know, in Minecraft, when you're digging a tunnel, this is now sort of my little face-on view. If you're digging a tunnel in Minecraft and you're busting blocks and you're making a tunnel, it's going to be 2 blocks high, your tunnel. And as you're standing in this tunnel, your eyes are like at this level, and you know, your body's here. You've got a block on your left. You've got a block, on your right. You've got a block on your left. You've got another block on your right and another block on your left. You're standing on a block, and you've got a block above you. In that one space, you've got 6 blocks around you. And if you have a 10 block long tunnel, then you've got 60 blocks exposed that you can see. So if you walk down a piece of tunnel, a section of tunnel that's 10 blocks long, you can count 60 blocks. If you count the amount of ore that you see around you in that 10 block tunnel, you're going to get a decent idea of how dense this deposit is, because the density doesn't change too much. It might be a little more dense towards the middle and a little bit more diffuse around the perimeter of the deposits, but on the whole, the density is pretty consistent. So let's say I'm walking down a 10 block tunnel and I'm looking up and down and all around, and I'm counting how many pieces of, in this example we'll say gold, how many pieces of gold I'm seeing. And if I count 12 pieces of gold on the walls and ceiling in this 10 block section, I have 12 out of 60 blocks, and that is 0.2. So my density is 0.2. Now, to calculate an ellipsoid, I'm not going to try to draw one here because it's not going to look good. It's not going to work out for anybody. You've basically got to run these numbers into a formula. And that formula, to find the volume of an ellipsoid, is 4 over 3 pi A, B, C, D. And this is probably where I should get a fresh page. Let's do this. Make a new. So we'll do our math right here. So volume, oops, what's going on? Volume equals 4 over 3 pi A, B, C, and D. Actually, that's not true. That's the formula here. This is something we're tacking on because we're not finding the exact volume of the ellipsoid. We're accounting for density, so we multiply it by the density. So even if I take that off, that's going to give you the volume of your ellipsoid. So maybe I will try to draw it. It's a circle, a sphere, but it's 3-dimensional, and you've got your width, and you've got your height, and then you've got your depth in 3D. And A, B, and C are these points from your centers. A is the depth, B is the direction of the center out to the edge, and C is also the direction of the center out to the edge. So when we look back here, I've got 30 blocks tall. This is actually, when we do D, remember we're going to take these values and we're going to find the radius. So it's actually not going to be 60 by 100 by 30 that we're going to use. We're going to use 30 by 50 by 15, the halfway. So if you're assuming that 15 is the halfway point, 15 blocks down is the halfway point, the true heart of the deposit. You've got these three values that end up being this. Volume equals 4 over 3 pi ABC. So that's 30, and that's times 30 times 50 times 15. All right, now I'm going to run that through a calculator. Let's see here if I can get that calculator going. And what do we end up with? So 4 divided by 3 times 3.14 times 30 times 50 times 15. So 94,200. Okay, come back here. Let's make a little note of that. If it was a solid sphere of gold, that's how many blocks would be there. But we know it's not solid because we checked the density. So what we want to do is we want to multiply that by our density, which was 0.2. So I'm just going to round this number off to 94,200 because it basically is that. And we multiply that by 0.2, and that tells us there's 18,840 blocks in there of gold. Now that's great. You've got that number, you know what that's worth. But when you're maybe a surveyor's work ordering an engineer and they say there's 18,840 blocks, like as an engineer, I'm going to go, okay, how much is it? We're talking like 10 chests, 100 chests. So, and surveyors can do us a favor by converting this to a standard unit of what we call chests, which is a wooden chest, not a double chest or a copper chest or an iron chest, just a wooden chest. 27 stacks of 64. So next thing you want to do for us is you know that stacks come in 64. So divide that by 64 and then divide it by 27. And now we know how many chests it is. So it's 10.9 chests. So basically it's 11 chests worth of gold. And then we know whether or not that's worth it. 11 chests worth of gold ore turns into 22 chests worth of dust and 22 chests worth of ingots. So that's a pretty sweet little gold deposit when you do the math on it. So that's pretty much how you survey. I hope that explains it. It's a little hard to see when you're doing it like this. It's a little bit easier in game when it's easier to sort of picture it in game because you've got the gold around you or whatever. But then again, you don't have the advantage of the bird's eye view like this. So lastly, when you're surveying this stuff and you're marking this stuff out for miners, they're going to need to see this in terms of surveyor flags. So that's where you take a nice color, maybe it's not the color of a flower, and you're planting these flags around the deposit. So this is what they need on the surface, the miners. So you plant a flag here and you run across the line. It doesn't matter. Like basically, there's no certain distance they have to be. Just if you're standing in one block and it's 10 flags, 10 blocks away or 15 blocks away, you just need to be able to see the next flag. From one flag to the next, we need to be able to see the next flag. So if there's a hill in between and you put a flag on the other side, they're not going to see it. So you go along here. And I'm just going to slam this down real quick. This is going to be nasty, but it's okay. You get the idea. And it shouldn't be wobbly like this. This should be perfectly straight paths when you do this, planting your flags. And that's great. So the thing about it, when you do this stuff where you're planting flags, one thing that's really important is if you're down here on the ground and you're looking at this and you're following this long line of flags and you're, as an engineer or as somebody else who's trying to figure out what you've marked out, they're going to just follow flag, flag, flag. They keep looking in this direction. All of a sudden there's no more flags. That's why we do this little thing. It's really important, is to put flags like this on corners. Wherever there's a turn and there's a block, we want, so here's the blocks, let's say. You want flags to be done, there's a flag here on this block. You come to a corner, there's a flag on that block, and there's a flag on that block. And, then you're going off in this direction. So you're coming along, you take the corner, it's these 3 flags in a row that let everybody know that you're turning here. And that's just a better way of marking out the perimeter. So that's how we want our surveyors to mark these corners, is with 3 flags on the corner like that. And especially important when you're laying routes through the wilderness for tracks, when engineers are trying to follow your work. It's really hard to tell when you're turning if you don't have that 3 in a row flag to indicate the corner. Okay, so I hope that explains the math behind how this stuff is done. It's the volume, it's the formula of an ellipsoid, the volume of an ellipsoid, plus we add in the multiplier of the density, because it's not a solid ellipsoid.